What is a product?
Substance produced by a chemical reaction.
What is rayon?
You probably know what rayon fabric looks or feels like. The best Hawaiian shirts. And much of 1980s fashion were made of it. What's fascinating about rayon is that it is not really a synthetic or a natural fiber. Rayon is a chemically modified cellulose polymer, first prepared in the 1850s. While there have been a number of ways of preparing this artificial silk, the viscose method led to the first commercial production of rayon. This method treated cellulose with a combination of sodium hydroxide and carbon disulfide as indicated below.
What is the boiling point?
Temperature for a given liquid at which its vapor pressure is equal to the external pressure acting on it.
Why did Ahmed Swail, Egypt/United States, win the Nobel Prize for Chemistry?
For his studies of the transition states of chemical reactions using femtosecond spectroscopy. Swail was awarded the prize for his work using ultrafast femtosecond spectroscopy to study chemical reactions in real time. That is to say, on the timescale on which they actually take place. Swail's earliest experiments in this area looked at iodocyanide and sodium iodide. He was the first to be able to observe the dissociation and recombination of a chemical species as it actually took place. His great advances in spectroscopic techniques revolutionized the field, and continue to do so today.
What is sugar?
A carbohydrate, a molecule composed of only carbon, hydrogen, and oxygen, that tastes sweet. Monosaccharides, or simple sugars, include fructose, galactose, and glucose.
What about the fake diamonds at jewelry stores? What are those?
Diamonds themselves cannot be made in a laboratory very well. But crystals with similar properties and appearances can be made. One popular type of simulated diamond is a cubic zirconia crystal, which is a crystal with the chemical formula ZrO2. Cubic zirconia are more dense than diamonds. Or, in other words, a cubic zirconia is heavier than a diamond of the same size. They are also a fairly hard material as minerals go. But they are not as hard as diamonds and can be scratched by diamonds. Cubic zirconia are usually colorless, which isn't the case for diamonds. Most diamonds contain some amount of non-carbon impurity that makes them appear colored. And only very pure diamonds appear colorless.
How do you measure the pH of a solution?
One of the first ways science students usually learn to test the pH of a solution is by using pH paper. This is a pretty simple test that only requires you to place a drop of the solution onto the paper and to look at its color. The color change accompanying changes in pH is due to a chemical indicator whose absorption spectrum changes with changes in pH. Another way to measure pH is with a pH-sensitive electrode. This can provide a more accurate measure of pH, as it digitally outputs the pH as a number value and does not rely on a person visually inspecting a color change to interpret the result.
What was the law of triads?
A scientist named Johann Dobereiner discovered trends in the reactivity of groups of elements. Certain sets of three elements, such as lithium, sodium, and potassium, showed similar chemical properties. And Dobereiner noticed that the average of the atomic masses of the atoms of the heaviest and lightest elements in the triad gave the atomic mass of the midweight element. For example, the mean of the atomic masses of lithium and potassium is 3 plus 19, / 2 equals 11, which is the atomic mass of sodium. Due to differing numbers of neutrons in each element and the existence of different isotopes. This law isn't always strictly true, but it does tend to work well, especially for lighter elements. For reasons we hope to explain in the coming questions. This trend plays an important role in the structure of the periodic table.
What does immiscible mean?
Unmixable liquids, e.g., oil and water.
What is the difference between a homogeneous and heterogeneous mixture?
A homogeneous mixture is one that is uniformly mixed and has the same proportions of components throughout the mixture. An example is a transparent solution of sugar dissolved in water. Specifically one in which there is no undissolved sugar floating around. A heterogeneous mixture is one that is not consistent or uniform throughout. Such as a glass of sugar water with some chunks of undissolved sugar also floating around.
What is the Curie point?
the temperature at or beyond which a ferromagnetic material becomes paramagnetic.
What are the alkali metals and alkaline earth metals?
The first two columns of the periodic table are known as the alkali, group 1, and alkaline earth, group 2, metals. The elements in both groups have very low ionization energies, which means they readily give up 1 or 2 electrons to reach a noble gas electron configuration, example Na+, Mg2+. In their elemental forms, these elements are soft, silver-colored substances. These elements are almost never found in their pure elemental state in nature because they quickly react with air or moisture, sometimes violently.
What makes something poisonous?
There are many ways to seriously disrupt our biological machine. Carbon monoxide binds to hemoglobin and prevents oxygen from getting to our cells. Cyanide shuts down the production of ATP in mitochondria. Hemlock is a weed that contains a mixture of at least 8 rather toxic molecules that target the nervous system. Thallium ions, Tl+, are particularly toxic because they are highly water-soluble and once in the body, they bind to ion channels and disrupt other processes that normally function with potassium ions, K+.
What is the Boyle's law?
Law stating that the pressure and volume of gas are inversely proportional.
What is an olefin?
A molecule containing a carbon-carbon double bond, also referred to as an alkene.
Why did Adolf Otto Reinhold Windaus, Germany, win the Nobel Prize for Chemistry?
For his research into the constitution of the sterols and their connection with the vitamins. Windaus was awarded the Nobel Prize for discovering that cholesterol, a sterol, was removed to cholecalciferol, vitamin D3, through a series of several steps. One of Windaus' doctoral students, Adolf Butenandt, was himself a Nobel laureate.
Why did Paul D. Boyer, United States, and John E. Walker, United Kingdom, win the Nobel Prize for Chemistry?
For their elucidation of the enzymatic mechanism underlying the synthesis of adenosine triphosphate, ATP, and YNC. SKU, Denmark, for the first discovery of an ion transporting enzyme, Na+, K+AT Boyer and Walker shared half of this prize for their work to understand how ATP synthase, an enzyme, catalyzes the formation of ATP. This information bears a crucial relationship to understanding how energy is stored, transferred, and used in cells. Scu received the other half of the prize for his work to discover the first ion transporting enzyme, which is responsible for keeping the balance of sodium and potassium concentrations in cells.
Why did Gerhard Ertl, Germany, win the Nobel Prize for Chemistry?
For his studies of chemical processes on solid surfaces. Surface chemistry is a topic of broad importance to many applied areas of chemistry. These include atmospheric chemistry, as some atmospherically relevant reactions take place at the surface of ice crystals, semiconductors, and solar energy capture, to name a few. Ertl was one of the founding fathers of modern surface science, and he played a role in developing many of the techniques used to study surfaces today. The study of well-characterized surfaces typically requires studies to be carried out under ultra-high vacuum conditions so as to avoid contamination of the surface, to be studied by any gas phase molecules that may tend to adsorb onto the surface,
How does baking soda make my cookies better?
Baking soda is sodium bicarbonate, NaHCO3, and is used in cooking as a leavening agent, as in, it helps things to rise. It does this by releasing carbon dioxide, CO2, which it does in the presence of acids, like buttermilk, vinegar, lemon juice, cream of tartar, and so on. The process is much faster at higher temperatures. Once you put your cookies in the oven, the sodium bicarbonate begins to break down, and the carbon dioxide that is released makes tiny little bubbles in the batter. These tiny bubbles get trapped as the cookies bake, making them light and fluffy.
How did chemists figure this out?
They analyzed fart gas by gas chromatography. No, really.
What is a dependent variable?
A variable that changes as a function of the independent variable.
How many different chemical substances have been discovered?
According to the Chemical Abstracts Service, CA, which is the world's largest authority for chemical information, The 70 millionth chemical compound was recently registered, announced December 2012. Today, new chemicals are being discovered and registered at a staggering rate. The 60 millionth chemical was registered only 18 months earlier.
Why did Richard R. Ernst, Switzerland, win the Nobel Prize for Chemistry?
For his contributions to the development of the methodology of high-resolution nuclear magnetic resonance, NMR, spectroscopy. Nuclear magnetic resonance, NMR. Spectroscopy has proven to be a powerful tool for physical and synthetic chemists alike. It has been used to characterize the structures of simple organic complexes, complex biomolecules, and to dynamically track the progress of chemical reactions, among other applications. Ernst won the prize for his substantial contributions to increasing the sensitivity and resolution of NMR instruments. Ernst contributed to improving a wide variety of aspects of NMR spectroscopy, including both ONI and two-dimensional approaches. And he also proposed a method for obtaining NMR tomographic images, which was eventually realized.
What is a Lewis structure?
Lewis structures are a simple way of depicting the electronic structure of atoms and molecules. They show us which atoms are bonded to each other in a molecule and also show how many non-bonded electrons are present in the valence electron shell of each atom. The easiest way to understand them is probably to just take a look at a few. The simplest Lewis structure is that for a single hydrogen atom, it has just one electron, and its Lewis structure looks like this. The letter H lets us know that it's a hydrogen atom, and the one dot represents its one electron. Here the two Fs let us know there are two fluorine atoms. The line connecting them shows that they are bonded with a single bond, containing two electrons. Each has 6 more electrons surrounding it, and these electrons are non-bonding. And finally, for a molecule with more than one bond, CH2O, this molecule is called formaldehyde. The Lewis structure shows us that the carbon is involved in a single bond, sharing 2 electrons with each hydrogen atom, and a double bond, sharing 4 electrons, with the oxygen atom. The oxygen atom also has 4 non-bonding electrons.
What is an actactic polymer?
A polymer in which the chiral centers are arranged randomly along the chain.
What causes dandruff?
Despite what you may have heard, dandruff is actually not caused by dry skin but rather by a specific type of fungus or yeast. While dandruff does cause flaky scales of skin to shed off of the top of a person's head, dandruff is actually due to the interplay between yeast organisms and natural oil glands. Unfortunately, there is no genuine cure for dandruff, but it can be controlled by using special shampoos containing zinc pyrithione, selenium sulfide, coal tar, or ketoconazole. To be effective, these products typically need to remain on the skin for several minutes before being washed away. In fact, the scalp is not the only place that dandruff can occur. Dandruff can also manifest on a person's eyebrows, mustache, and beard area, as well as the ears and the nose.
What is the Raoult's law?
States that the vapor pressure of a solution depends on the amount, mole fraction, of a solute added to it.
What is meteoric iron?
Meteoric iron is just what the name sounds like, it's iron that comes from meteors. For early civilizations, meteoric iron was one of the few available sources of relatively pure iron. That is, prior to when the extraction of iron from ore was discovered. Meteors containing meteoric iron are composed of mostly nickel-iron alloys. Iron meteorites often have a distinct appearance, and they are typically much easier to recognize than other types of meteorites. For this reason, they are discovered more often than other types of meteorites. Iron meteorites actually account for all of the largest meteorites that have been discovered.
What is electrochemistry?
Electrochemistry is a branch of chemistry that deals with electrons transferring between an interface and a molecule in an electrolyte solution. The interface is typically a conducting metallic material. Electrochemistry is a rich field that has led to the development of batteries. A widely used chemical separation technique called electrophoresis, a process for plating metals known as electroplating, and an immense body of knowledge surrounding oxidation reduction chemistry, among other achievements.
What is thalidomide?
Thalidomide is a drug that was once used to treat the symptoms of morning sickness during pregnancy as well as to help with sleeping problems. A few years after it became widely used, people started to realize that thalidomide was causing birth defects in newborns. These birth defects included phocomelia, abnormal formation of limbs, facial features, nerves, and other parts of the body, problems with sight or hearing resulting from abnormalities in the eyes and ears. gastrointestinal disorders, Passli disorder of the face, underdeveloped lungs, and problems with the digestive tract, heart, and kidneys. The use of thalidomide was then discontinued. Though even today there is still some research underway into its possible use in treating cancers. Similar to the situation with DDT, the problems that occurred during the use of thalidomide were particularly influential in motivating the government to tighten regulations on testing drugs and pesticides before their use.
Why do Diet Coke, R, and Mentos, R, fizz like that?
In Diet Coke, R, and all soda, there are a lot of CO2 molecules trapped in solution. The slow release of CO2 from solution is what normally makes the calm bubbling in soda.
Which energy sources produce the most CO2?
By far, it's the fossil fuels, oil, gas, and coal. It's the CO2 from all those combustion reactions that makes up about 96.5% of all the carbon dioxide emissions.
What do atomic orbitals look like?
There are three main shapes of orbitals relevant to most of chemistry. And these are referred to as s, p, and d orbitals. The designations s, p, and d are abbreviations for sharp, principal, diffuse, and fundamental, which have historical significance describing results of early experiments to probe the electronic structure of atoms. You can see what these orbitals look like in the graphic on the preceding page. The shapes of these orbitals are determined by their orbital angular momentum, which is a property that describes the motion of the electron around the nucleus.
What is a centrifuge?
A centrifuge is a machine that spins its contents very quickly and is used to separate the components of a mixture. The rapid rotation applies a force that causes the more dense components of a mixture to collect on the bottom of the centrifuge tube and the less dense components to rise toward the top.
What is an elimination reaction?
If an addition reaction adds two groups to a molecule, then an elimination reaction takes them away. The textbook example again involves carbon-carbon double bonds. But this time we're making that double bond. A molecule of base, hydroxide ion, O, causes the elimination of HBr. In this case, the process happens in one step, as shown.
Why does it get so hot when you pour a strong acid in water?
When a strong acid is poured into water, many proton transfer reactions take place very rapidly, and these are exothermic reactions. The fact that these reactions are exothermic means that they release energy, in the form of heat. Increasing the temperature of the solution before the heat has time to dissipate to the surrounding environment.
What is a superbubble?
A superbubble is a cloud of superheated gas that can be formed when multiple stars that are relatively near each other die out at similar times. This situation can lead to an explosion that spans hundreds of light years in distance. Recall that a light year is the distance that light travels through space in a year. So we are talking about an absolutely huge explosion. The light generated from this explosion is often not in the visible range of the spectrum, so they can't always be seen by the naked eye, not to mention the fact that they are also very, very far away.
How do nuclear power reactors work?
A nuclear power reactor works by generating heat from a controlled fission reaction, which then generates steam used to drive turbines to generate electricity. The fuel for the nuclear reactor is typically uranium-235 or plutonium-239.
How can I make hot ice, sodium acetate?
Chemistry principles encountered in this experiment. Chemical reactions, solubility, crystallization and recrystallization, colligative properties. Materials you'll need: pan with cover, microwave or stovetop vinegar, 1 liter, baking soda, 4 tablespoons, dish. The procedure: pour the vinegar into a pan, and very slowly, a little bit at a time, add the baking soda. As you may already know, this reaction will produce large amounts of bubbles. Carbon dioxide gas, so you'll need to add this very slowly. This reaction will produce a solution of sodium acetate in water. Sodium acetate is produced according to the chemical equation: Na plus HCO3 plus CH3COOH CH3 Co Na plus H2O and CO2. Bring the solution to a boil. Allow the solution to continue to boil until a skin or film begins to form on the surface of the solution. This will require heating for a significant amount of time, perhaps up to an hour, until a large fraction of the water from the vinegar has evaporated. Our goal here is to form a very concentrated hot solution of sodium acetate. You'll recall from our discussion of colligative properties that the solubility of a solute is higher at higher temperatures. As we reduce the volume of the water, the sodium acetate will not evaporate, and we will be left with a concentrated solution at high temperature. When you notice a film start to form on the surface, remove the pan from the heat, and cover it to prevent further evaporation. Place it on the countertop or in the refrigerator to cool. If you see any crystals begin to form, add a small amount of additional vinegar, or if you are out of vinegar, use water and stir the solution so that they dissolve. You now have a supercooled solution of sodium acetate that can crystallize out of solution readily if a crystallization nucleus is present. You can now slowly pour the first few drops of the cooled solution onto a dish, and it should begin to crystallize rapidly. If it doesn't, try dragging a fork or knife along the dish to make a tiny scratch. Or give the liquid a moment to evaporate a little so that the sodium acetate begins to crystallize before you begin to pour. As you continue to pour, the liquid should continue to crystallize as it contacts the crystals already formed on the dish. This is similar in spirit to how purification takes place during a recrystallization. See the modern chemical lab. If you feel the crystals, they will be warm to the touch. Since the crystallization is an exothermic process, it gives off heat. This is why it's called hot ice. But now you know it isn't really ice, it's sodium acetate, and you know how to make it.
What absorbs liquid in diapers?
The general term for the materials that absorb water in diapers is superabsorbent polymers. These same compounds are used to chill drinks and to make fire retardants and fake snow. Modern absorbing materials are typically sodium salts of polyacrylic acids, and these can become almost entirely water by weight and as much as 30 to 60% by volume.
Where are biomolecules found?
Biomolecules are molecules that are specifically found inside of living things and have some function related to life. This includes molecules found in plants, animals, insects, bacteria, or even viruses, which are often considered not to be alive in a technical sense. Biomolecules span a wide range of sizes, some weighing only about 50 atomic mass units, AMU, while others weigh millions of AMU. See atoms and molecules to review the definition of AMU. They are in our hair, skin, tissues, organs, and just about everywhere else in our bodies too.
Are hydrocarbons always straight chains of carbon atoms?
No. There could be carbon atoms attached to the linear chains we talked about in the previous question. Let's learn the next step in naming alkanes and have a look. First, we need to define the names of branches. See graphic, next page. Chemists use the same prefixes to indicate the length of the branch. But now the suffix is YL instead of ANA. So methane, CH4, when it's a branch off of a chain of carbon atoms, becomes methyl, CH3, ethane, CH3CH3, becomes ethyl, CH2CH3, and so on. Next we have to indicate where along the main carbon chain the branch point is. This part is pretty simple, just number the carbon atoms and put this number before the name of the branch. So if you had an 8-carbon chain, octane, with a 2-carbon branch, ethyl octane. On the third carbon from the end, it would be called 3-ethyl octane and look like this. There are a lot more rules to naming organic compounds, but that's enough for now.
What is ionization energy?
Energy required to remove an electron from an atom or ion, i.e., ionization potential.
What is a substitution reaction?
A chemical reaction that replaces one substituent with another.
What is an isomer?
Molecules with different arrangement of atoms in space, but the same molecular formula.
How do thermometers work?
There are actually many kinds of thermometers available. But let's talk about the two types that you probably have in your home. The first type is a glass tube filled with either alcohol or mercury. As the temperature rises, the volume of the liquid also increases, so it rises up the tube. The height of the liquid is calibrated with a scale so you can read the temperature value easily. The second type is known as a bimetallic strip thermometer. While you've probably never heard this name before, you've likely used this type of thermometer. They are the most common models of thermostats, before they went digital. Used as meat thermometers, oven thermometers, and the little thermometers that you see baristas using at coffee shops when they're steaming milk for your latte. You can tell from the name bimetallic that there are two metals involved here, usually steel and copper. In order to measure temperatures, these two metals need to expand at different rates when they are heated. If you make a strip of these two metals and wind that strip up into a coil, the difference in their thermal expansion will cause the coil to wind tighter or unwind as the temperature changes. Depending on which side of the coil you place the material that expands more. This coil then turns a needle to indicate that the temperature is rising or falling.
What is the difference between mass and weight?
Mass and weight are similar terms, but they have slightly different meanings. Weight tells us how much of something there is by telling us how much gravity is pulling down on it. Mass, on the other hand, just tells us how much of something there is, independent of the force of gravity on the object.
What separates ancient and modern chemistry?
While there's not a clear, punctuating distinction between ancient and modern chemistry, there are a few major differences that separate the two. Modern chemists describe the world in terms of atoms, molecules, and electrons and have a relatively complete understanding of the basic particles that make up matter, at least insofar as is necessary to describe chemical transformations. Ancient chemists didn't have this information and relied less on experimental evidence and more on theory and mythology. For example, ancient chemists sought the philosopher's stone, see below, for which there was no verifiable evidence. But they were attracted to it for its mythological power to preserve youth.
Why did Aaron C. Chanover, Israel, Avram Hershko, Israel, and Erwin Rose, United States, win the Nobel Prize for Chemistry?
For the discovery of ubiquitin-mediated protein degradation. While the overwhelming majority of biochemical research on proteins has focused on how they are synthesized and how they function, these three researchers took a unique path and studied how cells regulate their breakdown. They discovered that proteins are broken down and rebuilt at a much faster rate than anyone probably would have expected. Proteins are labeled when it is time for them to be broken down, and then they are chopped up into small pieces so that they no longer function.
What makes a material a good conductor of electricity?
Materials that are good conductors of electricity have many free electrons. Here we mean free in the sense that they are not bound strongly to a given atom or molecule. Metals are often good conductors of electricity. Whether or not a material has freely conducting electrons is related to the detailed electronic structure of the material, and a thorough description would be beyond the scope of this book. Basically, the more electrons that are free to move around in a material, the more easily it can carry current, and the higher its conductivity.
How can microwaves be used to promote green chemistry?
Microwaves are electromagnetic radiation in the frequency range of 0.3 to 300 GHz. When microwaves are absorbed by many substances, it causes their temperature to increase, thus heating a sample. This is also the same way the microwave in your kitchen heats and cooks food. Microwaves thus offer chemists the opportunity to use heat to promote reactions in cases where conventional heating methods are not possible. This can be useful for promoting reactions under green conditions, such as when we desire to heat the reagents involved in a reaction in the absence of a solvent.
What is a kilowatt hour?
A kilowatt hour, is a unit of energy representing the amount of work that is done by 1,000 watts of power operating for 1 hour. Notice that a watt represents a quantity of energy per unit time, also referred to as power, while a kilowatt hour simply represents a quantity of energy.
What is an indicator?
A substance that undergoes an observable change in response to a chemical input, e.g., pH, redox, presence of a metal ion.
How fast is Earth moving through space?
When taking into account the motion of the Milky Way galaxy, the fact that our solar system rotates within this galaxy, and the motion of the Earth within our solar system, it is estimated that the Earth is moving at about 500 kilometers per second. Of course, since everything around us is moving at the same rate, we don't tend to notice this.
What is the rate determining step of a reaction?
In a reaction with multiple steps, the rate determining step is the slowest step. It's the step that limits the rate of formation of the final products, usually because it has the highest activation energy.
What is specific volume?
The volume occupied by a compound per unit mass.
What is temperature?
Temperature is a measure of the average kinetic energy of particles in a substance.
What is an ohm meter?
A device used to measure electrical resistance.
What is an example of a multi-step chemical reaction?
Many reactions in biological chemistry, See also biochemistry, are multi-step chemical reactions. Glycolysis, which is the process of breaking down sugar to generate energy. For example, involves 10 sequential steps. Each step is carried out by a special type of catalyst, called an enzyme. There are countless multi-step processes in biological systems.
What is a calorie?
A unit of energy equal to 4.184 joules.
What is the condensation reaction?
A reaction in which two molecules combine to form one larger molecule, with the concurrent loss of another small molecule like water or HCl.
How did early chemistry relate to medicine?
Early societies all over the world found that certain types of plants could be used for medicinal purposes. Though only relatively recently have people attempted to gain a detailed understanding of the chemistry behind these methods. The overarching reason why these methods work is because a chemical in the plant interacts with the chemicals in your body in a beneficial way.
What are the transition metals?
Elements in the D block, groups 3 to 12, of the periodic table are referred to as transition metals. The lanthanides and actinides are usually excluded. With the exception of group 12, the transition metal elements have an incomplete d shell of electrons. The chemistry of these elements depends strongly on these d electrons. And most transition metals are stable in multiple different oxidation states. If the metal has any unpaired d electrons, it can have magnetic properties. Many transition metals have uses as catalysts in bond-forming reactions. And we'll talk about a few later in this chapter.
How can I make a cloud form in a bottle?
Note, this experiment involves fire and flammable materials. Adult supervision is a must. Chemistry principles encountered in this experiment: ideal gas law, phase changes, droplet formation, materials you'll need: 20 ounce or 1 liter plastic soda bottle, warm water, 1 to 2 ounces. Matches the procedure. Add warm water to the soda bottle until the bottom is just barely covered with water, with the bottle tipped so that you don't burn yourself. Ignite a match and insert the burning end of the match into the bottle. Allow the bottle to fill up with smoke. When the bottle is fairly filled with smoke, or when the match goes out. Remove the match and screw the cap on to close the bottle. Clouds will form when water vapor forms small but visible droplets around particles in the air. In this experiment, the smoke will provide these particles around which the water can form small droplets. With the bottle closed, squeeze it several times. You should see a cloud form when you squeeze the bottle. The temperature of the gas inside may temporarily increase, but the temperature will quickly equilibrate with the surroundings. Recall the ideal gas law we discussed in Atoms and Molecules, PV equals NKBT. When you release the squeezed bottle, the temperature inside decreases, cooling the water vapor and helping it to liquefy into droplets on the particles provided by the smoke. This is very similar to how real clouds are formed in the atmosphere.
What are some of the first organometallic complexes, and when were they discovered?
Among the earliest organometallic complexes was a compound known as cacodyl, or tetramethyldiarsine. This compound, with the chemical formula C4H12S2, shown below at left, was first discovered in 1760 and was known for its toxicity and terrible odor. The first platinum olefin complex, C2H4Cl3KPT, also known as Zeiss salt, see below, right, was discovered in 1829. This early organometallic complex was influential in establishing some of the essential underlying concepts that have since become crucial to organometallic chemistry.
Is everything made of molecules or atoms?
Basically, yes. The only material things that aren't made up of atoms or molecules are the subatomic particles that make up atoms. Anything you find around your house, office, or anywhere else is made of some combination of atoms that are on the periodic table.
If chlorophyll gives plants its green color, then what cells give me my skin color?
Melanin is the molecule that is responsible for skin color in humans. It's also what gives your eyes and hair their color. There isn't one single structure of melanin. Rather, it refers to a whole class of highly colored molecules that are all derived from the amino acid tyrosine.
What is a sigma bond?
A chemical bond involving direct overlap between orbitals on adjacent atoms. Sigma bonds are symmetric with respect to rotation around the bond axis.
What is a wave number?
Inverse of wavelength, typically reported in units of m1 or cm1.
Why are lasers useful for physical chemists?
Chemists use lasers to study how molecules interact with light. In some cases, a chemist may want to know how a molecule reacts when a pulse of light is used to excite it. In other cases, lasers can be used to gain information about the structure of the molecule. One of the reasons lasers are good for these purposes is that they can provide pulsed light to gain information about how molecules are changing over time. Another is that many tricks exist for controlling and manipulating the wavelength of the light produced by a laser, making them versatile light sources.
How many cells are there in your body?
An adult human is made up of approximately 50 trillion cells.
What is the law of conservation of matter?
The law of conservation of matter states that matter cannot be created or destroyed. This is relevant to chemical reactions because it tells us that we must have just as many atoms of each element at the beginning of a reaction as we do at the end of a reaction. In the example above, this is reflected by the fact that we use 2 molecules of oxygen, or 4 oxygen atoms from our reactants, to produce 1 molecule of CO2 and 2 molecules of H2O for a total of 4 oxygen atoms in our products.
How can I make glue from milk?
Chemistry principles encountered in this experiment: solubility, precipitation, filtration. Materials you'll need: hot water, from the tap, is fine, room temperature water 1 tablespoon. Of vinegar 1/2 teaspoon. Baking soda. Coffee filter cup, spoon, small bowl, tablespoons. Powdered milk. The procedure: dissolve 2 tablespoons of powdered milk in 1/4 cup of hot tap water. Mix in 1 tablespoon of vinegar and stir the solution well. Recall that household vinegar is a dilute aqueous solution of acetic acid. At this point the milk should begin to form little blobs of insoluble material, curd. These are a substance called casein, which are a class of proteins found in milk. Proteins are typically soluble in water and aqueous environments. But the acetic acid from the vinegar causes the casein to no longer be soluble in this solution. Position a coffee filter on top of a cup and pour the solution through the filter to collect the curd. To further dry the curd, try to use the filter to squeeze out any remaining liquid. Dispose of the liquid in the cup, dry the inside of the cup, and then transfer the curd from the filter into the now dry cup. Break the curd into smaller chunks using a spoon. This will help it to mix more readily with the ingredients you will add next. Add 1 teaspoon of hot water, and 1/4 of a teaspoon of baking soda to the cup, containing the chopped up curd. The mixture may foam a little from the reaction of the baking soda with the remaining vinegar, producing carbon dioxide gas. Stir this mixture, which should eventually become smooth and liquid-like. You may need to add a little more water or baking soda to reach a smooth, even consistency. Now you have your glue. You can use it just like you would any other glue, though you should test it out first, to make sure it's working well before you use it for that science fair project you're finishing up.
What is neuroscience?
Neuroscience refers to science that studies the way the brain and nervous system works.
Why do helium balloons float?
Helium balloons float because helium is less dense than air. So gravity pulls down on air more than it does on the helium balloon. The difference in density is enough that the displaced air supports the weight of the balloon and makes it float, up, and away.
What is a physical change?
A change in the macroscopic properties of a substance without a change in its chemical composition.
What is molecular orbital theory?
Molecular orbital theory is the other main theory. The first was valence bond theory, used to explain and predict bonding properties in molecules. Molecular orbital theory describes bonding interactions by using molecular orbitals that are spread out over multiple atoms. And this allows an electron's location to be described by an orbital that bonds atoms together in a more realistic way than valence bond theory.
What are sunspots?
A sunspot is a temporary spot on the sun that appears relatively dark. These spots are caused by magnetic storms that prevent convection from distributing heat evenly over the surface of the sun. This results in relatively cold areas of the sun. These spots may be as large as 50,000 miles in diameter, such that they can be visible from Earth even without a telescope, but that doesn't mean you should look at the sun.
What is ADP?
ATP, or adenosine triphosphate, is a molecule used as a source of energy in the body. The energy of an ATP molecule is stored in its chemical bonds, and it is released through hydrolysis of phosphate groups to form ADP, adenosine diphosphate. The ATP in our bodies is continuously recycled, and on average, each ATP molecule in our body will be used and regenerated over 1,000 times each day.
What are isomers?
Isomers are chemical compounds with the same molecular formula, but which are different in some way. The major types are constitutional isomers, stereoisomers, and enantiomers. The last one is actually a subset of the second to last one, but we'll get there in a minute. Constitutional, or structural, isomers have the same number of atoms, but they are arranged in a different order. For example, 4 carbon atoms and 10 hydrogen atoms can be arranged in 2 different ways.
Why did Marie Curie, née Sklodowska, Poland/France, win the Nobel Prize for Chemistry?
For the discovery of the elements radium and polonium. By the isolation of radium and the study of the nature and compounds of this remarkable element. Curie was the first woman to win a Nobel Prize. And she is still the only person to win in multiple sciences. Curie was a professor at the University of Paris. Another first why did she was the first woman on the faculty, beginning in 1900, and then at the Sorbonne in 1906, again why did she was the first female professor there. In 1903 she was awarded, along with her husband, Pierre Curie, and Antoine Henri Becquerel, the Nobel Prize in Physics for her work on radiation. In 1910, Marie isolated radium for the first time by electrolysis of radium chloride in the presence of hydrogen gas. This contribution was not enough for the French Academy of Sciences to elect her to their ranks. But a year later this accomplishment was recognized with Curie's second Nobel Prize.
What is the chelation?
Binding of a ligand to a metal atom through 2 or more positions.
So what is molasses, then?
Molasses is the byproduct of refining sugar cane. In one of the crystallization steps, the brown liquid that is left behind is concentrated into a syrup known as molasses. The molasses you may have used in cooking or baking is from sugar cane. Sugar beet molasses has a lot of other chemicals and it tastes terrible to us. Not everyone seems to mind though it's a common additive to animal feed.
When was NMR invented?
The first time NMR spectra were recorded was in 1945, and two different research groups accomplished this independently, one at Stanford and the other at Harvard. These groups were led by Felix Bloch, Stanford, and Edward Purcell, Harvard, who shared the 1952 Nobel Prize in Physics in recognition of their great discovery. See the list of Nobel Prize winners in chemistry in the back of this book. Pound. The location of the peaks along the x-axis is known as the chemical shift, and this value can be related to the electron density surrounding each nucleus. In some NMR spectra, the intensities of each peak, their height on the y-axis, can be related to the number of nuclei of a given element that are present. There are more and more details that one learns after spending lots of time interpreting NMR spectra. But these are the basic principles that allow a chemist to relate an NMR spectrum to a chemical structure.
Why did Karl Bosch, Germany, and Friedrich Bergius, Germany, win the Nobel Prize for Chemistry?
For their contributions to the invention and development of chemical high-pressure methods. Bosch worked with Fritz Haber on the synthesis of ammonia that today bears both their names, but was not recognized in the 1918 prize with Haber. Bergius developed a process for producing liquid hydrocarbon fuel from coal. Bosch also worked on the so-called Bergius process. After Bergius sold his patents to BASF, where Bosch was working at the time, the Bergius process and the Haber-Bosch process both operate at high pressures, and both methods had significant impacts on human history.
Why did Jacobus Henricus van 't Hoff win the Nobel Prize for Chemistry?
For discovery of the laws of chemical dynamics and osmotic pressure in solutions. The first Nobel Prize ever awarded went to van 't Hoff for his discoveries surrounding osmotic pressure and chemical equilibrium. If a solution of sugar water was separated from a volume of pure water by a membrane that allowed water, but not sugar, to pass, van 't Hoff discovered that additional water would force its way across the membrane until an equilibrium was established. This results in a greater pressure on the side to which the water is moving, and this pressure is known as osmotic pressure.
What is a s orbital?
An atomic orbital with an angular momentum quantum number of 0, shaped like a sphere.
What is an ion?
A charged atom or molecule.
What is a buffer solution?
A buffer solution is a solution that has a tendency to resist changes in pH. Even when an acid or base is added to the solution. Buffer solutions consist of a mixture of either a weak acid and its conjugate base, or a weak base and its conjugate acid, dissolved in water. When an acid is added, the base present in the solution tends to bind to the H end from the acid, serving to buffer the change in pH and preventing the concentration of H3O end from changing very much. Similarly, when a base is added, the acid in the solution tends to neutralize the base, again serving to buffer the change in pH by preventing the concentration of H3O end from changing significantly.